Okay, so this is page 34 for you guys. Okay. All right, so go ahead and do the warm-up. There's 2 problems here. Go ahead and work them out, then we'll check your results in just a second. Okay, here are my answers. Check to see if you got it right, or check to see that I got it right. Does that look right? Radius of 12, that doesn't look right. Is that totally wrong? Okay, great. That's the circumference, that's the arc length, okay. Okay, so the arc length, is that right though? 2 pi r. Yeah, that's right. Okay, so the arc length is right. And then a sector area is going to be, whole thing is 144 pi, 1/10 of that is 144 pi over 10, or 72 pi over 5. That's how you should present your answers, by the way, is improper fractions that are reduced, not decimals.
If you have a graphic calculator, if you just press this little arrow button right here, it transfers it.
Nice. Good for you. Okay, and then the last one, find the area and circumference of a circle with diameter of 3 radical 2. Circumference, that's easy, it's just pi diameter, 3 radical 2 times pi. And then the area is a little more tricky, a little more difficult, because you have to divide the diameter by 2 and then square it. So you got to be careful in your squaring.
Is that a 9?
18 divided by 4, which is 9/2, yeah. How are we doing? Okay, can we move on to new stuff? All right, let's do it. Here we go. Okay, so we have some really simple ideas that we're going to be playing around with in problems today, although once you start playing with them, they get super complicated once you start doing them in problems, right? All right, that's the way it goes. So here we go. Ratio of areas. First idea is this. There's three little, no, they're not really theorems, but rules that you can use to help you calculate ratios of areas. First one is this. If 2 triangles have equal height, the ratio of their area equals the ratio of their bases. And that makes sense because if you want to find the ratio of 2 areas and they have the same height, then when you set up the algebra, the halves cancel and the h's cancel, and all you're left with is the ratio of the bases. Okay? So, there's a simple relationship. One way to think about it is, let's say you have 2 triangles that are next to each other, right? So 2 triangles part of another triangle. So you're going to have 2 different bases here, right? 2 different bases, but they have the same height. So if you want to find the ratio of the areas of these triangles, well, it's just the ratio of the bases, because the 1/2 is going to cancel out and the height is going to cancel out. So that's kind of a simple way to think of those 2 problems, okay? Get the ratio of the areas. What your idea here is to find a shortcut trick to find the ratio of areas without actually calculating the area of each triangle. You could do that. That's kind of the long way. We're trying to teach you the short way, the shortcut tricks, okay? So, next one. If 2 triangles have equal bases, then the ratio of their area is just the ratio of their heights. Okay? Makes sense from the same argument. The bases are going to cancel out. Now here's a case where you might see something like that, where you have a triangle within a triangle. So you have a small triangle and you have a large triangle. They have different heights. What's the ratio of their areas? Well, they have the same base. So the ratio of their areas is just the ratio of their heights. Okay? And then the third one. If 2 triangles are similar. 2 triangles are similar, like the ones you see here, which are obviously not drawn to scale. You guys see that, right? Because that 4 looks like it's about half the length of the 12, so it's not drawn to scale. But if you know the scale factor, so what's the scale factor of the left to the right in this case? 3 to 1. Okay, if you know the scale factor, then you're going to know the ratio of the bases and the ratio of the heights. They're going to be the same, all 3 to 1. Which means that the area ratio is going to be 9 to 1. Because if you do 1/2 height times base, 1/2 height times base, you're going to get that 3 to 1 times 3 to 1, 9 to 1. Okay, so if 2 triangles are similar, then the ratio of their area equals the square of the scale factor. Okay? You have to square the scale factor if you have similar triangles. Do you guys remember how to show that two triangles are similar? There was a postula that we used. AA, right? Angle, angle. If you have two triangles and there are two angles that are congruent, then the triangles are similar. Okay, so look for angle, angle similarity when you're going to do some problems. Okay, theorem 11.7. If the scale factor of any two similar figures is A to B, okay, so any two similar figures, whether it's triangle or a rectangle or anything, turns out the ratio of the perimeters is just A to B. So if the scale factor of a triangle is 3 to 1, then the ratio of the perimeters is 3 to 1. Scale factor of a hexagon is 3 to 1, then the ratio of the perimeters of the two hexagons are 3 to 1. Okay, so the scale factor of the perimeter is exactly equal to the scale factor of the similar shapes. But the ratio of the areas is A squared to B squared. So in that case it would be 9 to 1. The perimeters might have the same scale factor, but the areas are going to be the square of that. Okay, so take a look at these, 4 to 12. What is the scale factor of this one? These two rectangles, what's the scale factor? 2 to 1. Okay, now go ahead and figure out what is the perimeter of the first one. Figure it out. Enzo, figure it out. What is the perimeter of the top rectangle?
Top rectangle is 32.
32. Good. What's the one of the bottom one?
18.
18. So,
No, 16.
12, 16. Yeah. So 32, and then the second one is going to be 16. So what do you notice about the ratio there?
It's 2 to 1.
It's 2 to 1. So the scale factor is the same as the perimeter. Okay, I just sort of did a little example to show you that it was true. Okay? If you know the scale factor, you know the perimeter ratio also. Find the areas. Okay? Let's see. Frankie, what is the area of the top rectangle? 48. What's the area of the bottom rectangle? 12. So what's the ratio of their areas?
1 1.
Yeah, 48 to 12, which is 4 to 1. Okay? Which is what we said, that if you have a scale factor of 2 to 1, then the ratio of the areas is A squared to B squared, or 4 to 1.
So it's the prior, or the previous ratio squared, not any of the lengths.
You have to figure out the scale factor. All you need to know is the scale factor.
Right.
So typically I'm not going to ask you to find the ratios. I had you actually find the areas in this case to show you that it was true. But typically if you know a scale factor, your work is to find the scale factor, because once you get the scale factor, bam, you got the area ratios and you got the perimeter ratios. All right. Diameters of two circles are 10 centimeters, 9 centimeters. What is the ratio of their circumference? Let's see. Who am I going to? Kieran. What is the ratio of their circumference? It is 10 to 9. Yep. Exactly. Okay, the circumference is going to be the same. That's the perimeter, right? Circumference is the same as the perimeter of a circle, right? So the ratio is going to be 10 to 9. What is the ratio of their areas? Yep, that's exactly right. 100 to 81. Okay, and I'm showing it as you work it out. If you want to do the ratio of the circumference, the pi's are going to drop off, so it's just 10 to 9. Ratio of perimeters is the same as the scale factor. In that case, it was 10 to 9. Areas, I'll work it out for you. The pi's cancel out. You get 100 over 81. There's your ratio. Okay. Two similar polygons have a scale factor of 3 to 4. The area of the small polygon is 135. Find the area of the larger polygon. All right, so here we go. How are we going to work that one out? Well, the scale factor is 3 to 4. So what do you know about the area ratio? It's not 3 to 4. It's 9 to 16. Okay, so you could say that since the area ratio is 9 to 16, and 1, the small, that's going to be the ratio of the small to the large, right? The small area to the large area, because 9 is smaller than 16. Yeah. Okay, so then the small is what we're trying to, small is what we know. We're trying to find the large. Ooh, I might have set it up wrong. We told the small. Oh, I did it wrong. Okay, let's do it right. So it's going to be the small is 135, and the large is what we don't know. Okay? So if the large is, then now how are we going to solve that? Well, let's call the large x, and then we're going to cross multiply them. We're going to get 9x equals 135 times 16. I hope someone has a calculator because I don't. Equals 135 times 16 divided by 9, which is?
It's 2,160 divided by 9.
2,000 what?
2,160 divided by 9, which is 240.
2,160 divided by 9. Okay, I'm going to leave it there for that. Okay? There you go. You got the idea? So just set up a little ratio. You know the area ratio because you're given the scale factor. Figure out what you know, the small or the large, and then find the missing value. Just a proportion problem.
Could you do like solve for x, like 3x squared equals 35, and then just plug that in?
You could do that too. Ishan, end of the period. Helen is not here today. You're welcome. Ishan is not here today either. Thank you. Sorry. Okay. All right. And those are all wrong because I did the wrong ratio, so let's fix it real quick. Okay, and then I have another problem that is not on your worksheet that I want to show you, and it comes very similar to a homework type problem. Okay, so just take a look at this one. Oh, you have some space, so you could draw this one out on your side of your page. Okay, so let's go ahead and draw this one out. So you have a circle. You have a point A, Ben, external to the circle. And the line comes in and it intersects with point D here at the circle edge, and then point E over here, and then B and C. So go ahead and draw that out, and then we're going to go over it. Okay, so I filled in some values for you. You have 9, and you have 11, and you have 10. It says, name two similar triangles and find the ratio of their areas, and then find the length DE. So the first trick is to find two similar triangles. Take a look at those and see the similar triangles. See if you can find them. You need to have angle, angle to prove similarity. So you know that angle C is congruent to angle E because they both intercept the same arc. And what's the other angle? Angle A is congruent to itself and is part of the same two triangles. Oh, you're going to go with some vertical angles?
Yeah.
Okay. Yeah, I guess those are two. Okay, yeah, so there's probably more than one. I guess I came up with a pair, but maybe there's another set as well. So I'm saying I'm going with ABE is similar to ADC. Did you guys find, well, I didn't really label that middle point, but maybe those, are these two triangles similar as well? Yeah, looks like they are. Yeah, you could show that those are two similar. Okay, so now, find the ratio of their areas for ABE and ADC. Hint, do not actually calculate the area. Use what we learned in this chapter section. Namely, if you know the scale factor, then you can find the area ratio. So see if you can figure out what the scale factor is. What's the scale factor? 10 to 9. Or if you're talking about ABE to ADC, I would not say it's not 10 to 9, I'd say it's 9 to 10. Okay? And I'm looking at AB and I'm looking at AD, and they are corresponding parts of similar triangles, aren't they? And since one side is 9, the other side is 10, the scale factor is 9 to 10. Right?
What's the difference between like ratio and scale factor?
What's the difference between ratio?
Yeah, like
Well, I'm talking about an area ratio. Scale factor is a ratio too, but it's more of a side-to-side ratio as opposed to an area-to-area. The scale factor is the length of one side compared to the other. The area ratio, you have to get the area. So now knowing the scale factor is 9 to 10, what is the area ratio of triangle ABE to ADC? It is 81 to 100. Okay, you got it? Okay, so the tricky part is figuring out the similarity triangles, and then you got to get the scale factor. You got to find the corresponding parts to figure out exactly how they're corresponding and what the similarity scale factor is. And then once you get the scale factor, again, the area ratio is easy because you know if the scale factor is A to B, then the area ratio is A squared to B squared. Okay? All right, you have the remainder of the period to begin your homework.